Homework 5.1, Systems of Equations, Video 3. Homework due Friday, May 29th at 11:59 p.m. This video and the preceding video are associated with homework questions 1 through 4. In the previous video, we created a technique for solving a 2x2 system of equations, linear system to be specific, by substitution. And for the record, this would work for nonlinear systems sometimes, always for linear systems. So I've got another example that illustrates a problem that was brought up at the end of the previous video. In the previous video I said, when you're solving either equation for either variable to set up your substitution, you should choose you should choose a variable whose coefficient is either 1 or -1. That will avoid creating fractions unnecessarily. But what if none of the coefficients are 1 or -1? It matters not which x or y we pick. They all have coefficients besides 1 or -1. They all will require dividing to finish solving for it. They will all create fractions. If I pick this y, at some point I have to divide by 2 and nothing else in the equation will. If I pick this x, at the end I have to divide by 3 and nothing else will. Doesn't matter in this case. So what do we do if none of the coefficients are 1 or -1? The answer is, suck it up and do it anyway. Because this procedure doesn't care whether you have fractions or not. I know, fractions are scary, fractions are hard. Those are misconceptions. As with any problem, stay focused, have a plan of attack, move forward carefully, and everything will be okay. So let's try this one. Step 1, solve either equation for either variable. There's no clear-cut winners here. So let's just pick the first x. Let's take 5x plus 2y equals 33, and let's solve for x. Why? Because I have to pick something to solve for, and I just picked that. If you don't like it, fine, pick something else, and we'll get the same answer as long as we both do our steps correctly. If I want to solve this for x, the first thing I need to do is subtract 2y from both sides. So I get 5x equals -2y plus 33. Then I have to divide everything by 5. And nothing wants to divide by 5 on the right side. That's okay. I could put it all over 5, but I'm going to split it into 2 fractions. -2/5 y plus 33/5. From experience, I just know that writing it as 2 smaller fractions instead of 1 giant fraction usually is a little bit more tolerable. But this is our substitution. This says, anywhere there's an x, we may replace it with -2/5 y plus 33/5. And remember, when you use the substitution to rename a variable, you do it in the other equation and you use parentheses. So let's go to the other equation. We use the first one to create the substitution, so we'll use the other equation to implement the substitution. And since it says x equals, I'm going to replace this x with parentheses. 3 big old parentheses minus 8y equals -17. Kind of running into the steps over here. All right, let's make our substitution. So -2/5 y plus 33/5 goes in here. And I know this looks really intimidating, but trust me, you can do it. So how do we solve that? Well, ignore the fractions for a second. I need to distribute the 3. Oh no, I have to multiply, but you're multiplying fractions, and that's the easy thing to do with them. To multiply, you multiply numerators and you multiply denominators. The 3 currently is not a fraction until I put it over 1. But now multiplying it is easy. 3 times -2/5 y. First off will be a y term, and will be negative. Positive times negative. On the top, 3 times 2 is 6. On the bottom, 1 times 5 is 5. That wasn't too bad. On the second half of the distribution, positive times positive is positive. On the top, 3 times 33 is 99. Insert your own Jay-Z joke there. On the bottom, 1 times 5 is 5. Again, not too terribly bad. And we have the rest, minus 8y equals negative 17. Now we got to deal with the fractions. If those were not fractions, what would you do next? Probably combine these like terms. So guess what we should do because they are fractions? Actually, we could combine the like terms if you wanted to get a common denominator and do that. But I think I've said this before, but I'm going to say it again more emphatically. If you are solving an equation with fractions, it is in your best interest to eliminate the fractions as soon as possible. How? A fraction is just a division problem. This says 6 divided by 5. This says 99 divided by 5. How do you undo dividing by 5? Times 5. At this point, I would immediately get out a times 5 on each side of the equation. Negative 6/5 y plus 99/5 minus 8y equals negative 17, and then multiply both sides of the equation by 5. You may want to have a calculator handy, but when the 5 hits the fraction, it cancels its denominator. So 5 times negative 6/5 y is just negative 6y. 5's cancel. Same thing with the next fraction. 5 times 99/5, the 5's cancel, plus 99. Now on the third part of the distribution over here, there is no fraction, so I'm actually going to multiply by 5. 5 times negative 8y is negative 40y. And on the right side of the equation, there are no fractions, so I have to do negative 17 times 5, which is negative 85. Again, feel free to use a calculator to facilitate the multiplying. Hooray, no more fractions. I still got to solve this, but you know how to do this. There's too many y's, I got to combine them. Negative 6y, negative 40y is negative 46y. I want to cut something off. I saw this in somebody's scratch paper. Don't do this. Warning, this is wrong, so pay attention and don't do what I'm doing right now. Do you see what's wrong with that move? I understand the intention. I want to cancel the 6y, but do you see what's wrong with it? The rule is what you do on the left side of the equation, you do on the right side of the equation. I did the same thing twice on the same side. If I want to do that move, that's fine, but you would have to do plus 6y over here on the opposite side of the equation. When they are on opposite sides, that's when you get rid of one of them. But when they are on the same side, put them together. So I'm not going to add 6y or add 40y to anything. I'm going to combine the negative 6y and the negative 40y to get negative 46y. Plus 99 equals negative 85. The size of the numbers are irrelevant. Just finish solving it. Subtract 99 from both sides, and we'll get negative 46y equals negative 184. This could turn out bad, because I know what the last move is. It's divide by negative 46, and 45 out of 46 times dividing by 46 doesn't come out well, but negative divided by negative is positive, and 184 divided by 46 is exactly 4. That wasn't too bad. Oh, we're not done. We just solved for the remaining variable. It's time to use the substitution. So back to the substitution, which did involve fractions. X equals negative 2/5 times y, which was 4, plus 33/5. Now, if you're thinking, should I multiply both sides by 5? You could, but take a deep breath and jump in. This isn't as bad as it seems. I know I'm supposed to multiply first, order of operations. I know the rule for multiplying fractions, so I'll put the 4 over 1. So the multiplication problem, negative times positive is negative. On the top, 2 times 4 is 8. On the bottom, 5 times 1 is 5. I'm adding that to 33/5. Now I have to add the fractions, but they already have a common denominator. So I keep that and add the numerators. Negative 8 plus 33 is 25. And 25 over 5 is 5. So our answer is 5, 4, which is the answer I had in mind when I made up the system. So, the point of this example is to show you two things. Number one, Don't be intimidated. If you have a good plan, stick with it, and every time a new obstacle presents itself, just ask yourself, what move should I take to overcome that obstacle? And number 2, this technique will always work, even if it gets ugly. You just have to stick to it. But it sure would be nice if we didn't have to drag ourselves through all these fractions to get it done. Guess what? We don't.